In the last video, I gave you one example on how to find out eigenvalues and eigenvector of a 2 by 2 square matrix, right? And then the example we did had two distinct eigenvalues, okay? One was, I think that was 1, and the other eigenvalue was -5, okay? 1 and -5. Now, I'm going to show you a couple more examples where the eigenvalues are repeated, the same eigenvalues. Two eigenvalues are the same. So let us do first one example that has a repeated eigenvalue case. Okay, guys. So how do I find out the eigenvalue here? Okay, so let us suppose that lambda is the eigenvalue. So let lambda is you can say like this. So lambda and, okay, so lambda and v equals to, let's say, x, y are eigenvalues and eigenvectors. Eigenvalues and eigenvectors of matrix. It is 2 by 2 matrix, right? Because it has 2 rows and 2 columns, matrix A. Then what? Then we need to find out the eigenvalue lambda, right? How do I find out eigenvalue lambda? Then we write AV equals to lambda V, right? So if you write that, you can write A minus lambda I and then V equals to 0, right? So what is our matrix A? Matrix A is 1, -1, and then 4/9, and then -1/3, right? And then minus by the way, yes, that's fine. Then we will get that, and then minus, what do we do? That is A minus lambda I is lambda, and then I is 1 0 0 1, right? That is, and then V equals to 0, right? This is from the definition, okay? So I'm keeping V, but I'm not finding out the characteristic equation 8. I'm just doing some simplification here. If I simplify that to a single matrix, what happens there is 1 minus lambda, right? And then -1 minus lambda times 0 is 0. And 4/9 minus lambda times 0 is 4/9. And then that will be -1/3 minus lambda, right? This is what you get, and then times v, vector v equals to 0. So what is the characteristic equation? Characteristic equation is the absolute value of, or the determinant of A minus lambda I equals to 0, right? So this is the A minus lambda I. So we need to find out that determinant equals 0. The characteristic equation, characteristic equation is, what you get is A minus lambda I equals to 0, the determinant. That means 1 minus lambda, 0, 4/9, and then -1/3 minus lambda equals to 0, right? Now how do I find out the determinant of this? It is just multiply this one positively and this one with a negative sign, right? So you get 1 minus lambda times -1/3 minus lambda, right, minus 4/9 times 0, okay? What do you get? Oh, by the way, this is not 0, right? This is -1. So this will be -1 minus lambda times 0 is -1, right? So that value is basically -1. Let me write down that. So -1. So 4/9 times -1 is -4/9, but that is negative multiplication. That will be positive 4/9 equals to 0. Now if you simplify this, what do you get? 1 minus -1/3 will be -1/3, and 1 minus negative lambda will be negative lambda. Negative lambda times -1/3 will be positive lambda, 1/3 lambda, right? And then negative lambda times negative lambda will be positive lambda square, and then plus 4/9 equals to 0. You see that? So if you simplify this, you will get lambda square, and then so minus lambda plus lambda third. So it is 3 lambda over 3. This is plus 1 lambda over 3 will be 2 lambda over 3, right? So now this one is number, that one is number. So this is 4/9, this is 3/9, right? 4/9 minus 3/9 will be plus 1/9 equals to 0, okay? So how would you write this? So you can multiply by 9 on this equation, then you can find out that, or you can use the quadratic formula to solve this, or you can do the factors. Okay, so we need the sum must be 2/3, negative 2/3, and product must be 1/9. What are those? Lambda minus 1/3 and then times lambda minus 1/3. See, the sum is negative 2/3 and the product is positive 1/9 equals to 0. So you get, see, you get 1/3 and then 1/3, right? So repeated roots, repeated eigenvalues. So that's the repeated eigenvalues you got. So the characteristic equation, we took that and then we simplify that and then we got a repeated eigenvalues. Okay guys, so we need to find out the eigenvectors. So what are the eigenvectors then? Okay, so next is for eigenvectors. For eigenvectors, how do I find out the eigenvectors? We do AV equals to lambda V, right? But what we consider for B, XY. So what we do is, what is our A is 1 and then 4/9, right? And then negative 1 and then negative 1/3. You see that? And then V is X comma Y and then lambda is 1/3, right? Both lambda are 1/3, so you don't have to do twice, just X, Y. So AV equals to lambda V. Now let us simplify that. What do you get? How do you multiply? 1 times X, negative 1 times. It is like the multiplication looks like this, right? And then multiply with that, right? So what do you get? 1 times X is X, right? So what do I get there is X minus Y equals to 1/3 X. You see that? This times that. I mean, I can write like this. Not a problem for now. So on the left side, I got X minus Y for the first line, and for the second line, 4/9 X minus 1/3 Y, right? So 4/9 X minus 1/3 Y equals to 1/3 Y again. You see that? So what do you get then? So basically, if you set them equals, you will get X, the first one will be equal to first one, X minus Y equals to 1/3 X, right? And then 4/9X minus 1/3Y equals to 1/3 Y. From the first one, what you need to do is you need to bring that 1/3 to the left side and then Y to the other side. What do you get? So from the first one, you will get 2/3 X equals to Y from the first one, right? 2/3 X equals to Y. And then how about from the second one? From the second one, you will get this 4/9 X equals to 2/3 Y, right? So from the second one, you get 4/9 X equals to 2/3 Y. Okay, so if you divide by 2/3, what do you get? You will get 2/3 X equals to Y again if you divide both sides by 2/3. Okay, so basically you get the same equation. That's what you expect to have. Now, so the equation is 2/3 X equals to Y. Now I need to find out the value of X and Y. So what I want to do here is I want to put, if I put X equals to 3, what do I get? That will cancel out with that, right? And you will get 2X equals to Y, right? So 2 equals to Y in that case. So set X equals to 3, you get Y equals to 2. So the vector V is basically, you can write 3, 2. That is the eigenvector. Okay, you see that? This is the eigenvector. So you can have any values of X that is multiple of 3 to get another integer value for Y. Okay, so basically these eigenvector, this problem has only one linearly independent eigenvector, I would say. Okay, but previous example had 2 eigenvectors. You see that? What do you mean by linearly independent and linearly dependent though? So linearly independent means the two vectors are linearly independent if one cannot be written as the multiple of the other, but linearly dependent means one can be written as the multiple of the other. Okay, so it has only one linearly independent eigenvector, so all other eigenvector will be linearly dependent with this. But in the previous example, we had 2 different eigenvectors that you are not able to write one eigenvector as the scalar multiple or the multiple of the other eigenvector. Okay, so this has only one linearly independent eigenvector. Alright, so I am going to give you another example. Let me see. So another example is find the eigenvalues and eigenvector of this matrix. Okay, so let lambda and v equals, let's say, x, y are the eigenvalues and eigenvectors respectively, right? Lambda is eigenvalue and the v is eigenvector. Then by definition AV equals to lambda v, right? Do exactly the same step. So how do you write that? Do you write that? If you bring to the left, you can write a minus lambda I v equals to 0. So what is a minus lambda I? A minus lambda I will be, so 3003 minus lambda times 1001, and then v equals to 0. Okay, so for matrix you can close by bracket or parenthesis, that's fine. So if you simplify that, you will get 3 minus lambda 0, and then 0, 3 minus lambda, v equals to 0. So what is the characteristic equation? Hence the characteristic equation is what we do to find out the characteristic equation. We take the determinant of a minus lambda I, right? So don't take the v for the characteristic equation, just that take the determinant of that one only. So you get 3 minus lambda 0, 0, 3 minus lambda equals to 0. So how do I find out that? You multiply this positively, you multiply that negatively, right? So you get 3 minus lambda square equals to 0. So if you solve this, you will get lambda equals to 3. It is repeated again, right? Repeated again. So how do I find out the eigenvector? For eigenvectors, what do you do for the eigenvectors? We do AV equals to lambda v, right? That is A is 3003, and then you get xy, that is v vector, equals to 3, and then xy. You see that? Now simplify that. 3 times x is 3x, 0 times y is just 0. So 3x, this was 0 times x, 3 times y, 3y equals to, you get 3x, 3y, right? So what do you get? 3x equals to 3x. If you subtract 3x, you will get 0, 0 equals to 0. Similarly, on the second one, you get 3y equals to 3y again. If you subtract 3y from both sides, you will get 0 equals to 0, right? So here, we don't have anything left actually, right? So you can pick any values of x and y. Here you are free to pick, you are free to pick x and y values. Okay, so y values, so hence the eigenvectors, are free to choose, but they must be independent. Okay, this should be independent, because if you write the dependent, then they are actually not different. I mean, they look different, but they are linearly dependent, meaning that one is the multiple of the other one. Okay, they should be independent. Okay, so let v1 equals to 1 comma 0, and then v2 equals to 0 comma 1. So these are the very basic linearly independent, two linearly independent vectors. So you are free to choose any values of x and y. I just pick 1, 0 and 0, 1, but these are the very basic linearly independent vectors. So let me tell you about what do we mean by linearly dependent and linearly independent. Okay, so I want to talk about that. So let us say that V is a vector that is, let's say 1, 2, and then let's say W is another vector, and then let's say this vector is given as 3, 6. Do you think they are linearly dependent or linearly independent? See, you can write W equals to 3 times V, right? You see that? This is the multiple of that one. So they are linearly dependent. They are linearly dependent. So you will see more about linear dependence and linear independence in your linear algebra class, okay? But for now, just think that if one vector can be written as the multiple of the other vector, it is called linearly dependent, okay? If you cannot do that, then it is linearly independent, okay? So here, if you have 1, 0 and 0, 1, they are always linearly independent because you can write one vector as the scalar multiple of the other vector. All right, guys, that's a very brief intro of the linearly dependent and linearly independent. It has more than that, okay? You will see that there is a linear combination of other vectors if there are more than 2 vectors, okay? But in the simple word, these are linearly dependent and linearly independent. For example, another one can be, let's say, vector u is equals to, let's say, 1, 2, and vector v is equals to, let's say, 0, 5. They are linearly independent as well because there is no way that you can write u as a multiple of v because there is 0 there, right? And there is no way that you can write v as a multiple of u, okay? So they are independent. So in the last examples, all the examples that we found eigenvalues and eigenvectors, we had the eigenvalues real numbers, and eigenvalues and eigenvectors were real numbers too, right? I mean the real vectors too. So can it be a complex eigenvalues or a complex eigenvector? That's what we want to talk about next, okay? So let me take an example. Let me take an example that has a complex eigenvalues and complex eigenvector. How do I do that? Let me do example. So find the eigenvalues and eigenvector of the matrix A equals -4, -17, and then 2, 2. Okay. So how do I do this? Is we assume that lambda is the eigenvalue. Let lambda and v equals to, let's say, x, y be the eigenvalue and eigenvectors. Eigenvalues and eigenvectors. Then what is the definition of that? You write a v equals to lambda v, right? You write a minus lambda I, right? And then v equals to 0. You see that? So what is the characteristic equation? So the characteristic equation is the absolute value of that, but I mean the determinant of that. But how do I find out what is a minus lambda v? That is -4 minus 17 2 2 minus lambda times I will be what? Lambda 0 0 lambda, right? Because I is 1 0 0 1. When you distribute lambda to each of them, that's what you get. And then that is there, and then v is outside, so you get -4 minus lambda -17, and then 2 minus lambda. You see that? That is the a minus lambda I, and then v is outside equals to 0. So let us find out the characteristic equation. So thus the characteristic equation is the determinant of that, right? 4 minus lambda -17, minus 4 minus lambda, right? 4 minus 17, -4 minus lambda. So 2 and then 2 minus lambda equals to 0. See, this multiplication is positive. You multiply this negatively, that will be -4 minus lambda, parenthesis 2 minus lambda, and then plus 34 equals to 0. Why? Because 2 times -17 is -34, but this multiplication is negative, so that will be positive 34. Okay, so if you simplify this, what do you get? Let me simplify that. So you'll get -4 minus 2 is -8, positive 4 lambda, right, minus 2 lambda, and then plus lambda square plus 34 equals to 0. So what do you get? You get lambda square plus 2 lambda, right, plus 34 minus 8 is 26. So lambda square plus 2 lambda plus 26 equals to 0. So we cannot factorize this. So what I'm going to do is I'm going to use the quadratic formula, okay, quadratic equation. So what is that? Lambda equals to -2 plus minus under the root b square is 4 minus 4a is 1, c is 26, divide by, what do you get? You get 2 times a is that. So it is -2 plus minus under the root. What is 4 minus 26 times 4 is 104, okay. Minus 4 will be -100, you see that, divide by 2. What do you get? You get -2 plus minus, what is negative root under -100 is 10i, right, divide by 2. So that will be -1 plus minus 5i. So that's the two values of lambda, right? So lambda is equals to 1 plus 5i, -1 plus 5i, and then -1 minus 5i. So it sounds like they are conjugate to each other, right? You see that? So if a minus lambda I, sorry, a minus a plus bi is eigenvalue, then its conjugate is also eigenvalue here. Okay, now what we want to find out is we want to find out the eigenvector. So for eigenvector, so for each of the eigenvalue we'll find out the eigenvector. Okay guys, of the eigenvalue lambda equals -1 minus plus 5i. If you do that, what do you get? AV equals to lambda v, right? A is -4, -17, and then 2, and then 2. V is xy, right? Equals to lambda is -1 plus 5i, and then xy. Okay, guys? So exactly the same method, all right? -4x minus 17y, and then 2x plus 2y, so equals to -1 plus 5i x and -1 plus 5i y. That's what you get. Now what you want to do is you want to set them equal, so the first equals to the first one, okay? So on that, what I'm going to do here is I am going to solve just write x in terms of y, kind of, okay? So how do I do that is from the first one you get -4x minus 17y equals to -1x plus 5ix. You see that? I'm just distributing that x to both of these. And what you do that is, let's add 4x on both sides. What do you get? You get -17y is equals to 3x plus 5i. You see that? X. Okay? So basically you get y equals to 3 plus 5i over 17, and then -17. You can write negative here, x. This is what you get. Y equals to that value. Okay, so if you solve the second equation, you must get exactly the same equation. You will get exactly the same equation. Okay, so what I'm going to do here is I want to write down some values of, because I need to find out the vector, right? V equals to xy. So what should I pick for x in order to get another value for y? I mean, you can take x equals to 1. That is perfectly fine. You can take x equals to 1. Or x equals to some other value, so that you will get y equals to some number. You see that? So one way of writing that is, let's say, set x equals to 1. If you set x equals to 1, what do you get for y? You will get y equals to -3 plus 5i over 17. That's what you get. So what is the vector v? The vector v will be 1 and then 3 plus 5i over 17. This is one way, okay? But another cleaner way is, if I said x equals to 3 plus 5i, then I can multiply this 3 minus 5i, then you can multiply 3 plus 5i and 3 minus 5i, and then you will get something nicer, okay? Instead of that fraction, you will get something nicer. So for that, you can do, if you said x equals to, why did I pick 3 minus 5i? Because I know that if I take x equals 3 minus 5i, I can multiply with that, okay? Then you get, then y will be negative is here, right? 3 plus 5i over 17, right? And then times 3 minus 5i. See, it is a plus b times a minus b. So what do you get? You get negative, and then 3 times 3 is 9, and then 3 times negative 5i, and 5i times 3 will cancel out. So 5i times 5i is minus 25i square will be negative 25. You see that, over 17. What do you get? Basically you get, so 9 plus 25 is 34, divided by 17 will be negative 2. You see that? If you take x equals to 3 minus 5i, if you take x equals to 3 minus 5i, then basically what you get is, y equals to negative 2, right? So the answer will be, you can write vector v is, you will get, so what was the x value? 3 minus 5i and then negative 2. You can write this nicer form instead of having the fraction there, okay? But both of them are right, all right? So to find out another eigenvector, because this is the first eigenvalue I took to find out the eigenvector. So for the next one, I will do the similar thing. For lambda equals to negative 1 minus 5i, I'm taking the second eigenvalue. You do lambda v, a v equals to lambda v, and simplify, okay? A v equals to lambda v implies a is negative 4 minus 17, and then 2, this is a. V is xy, right? Lambda is negative 1 minus 5i and then xy. You see that? So negative 4x minus 17y, 2x plus 2y equals to, so negative 1 minus 5ix and negative 1 minus 5i y. You see that? This is one matrix. This is another matrix there. And then let me write down the equal sign in the middle for now, and then I will compare each of them, okay? So negative 4x minus 17y equals to, so what is the second equation? The second equation is 2x plus 2y equals to negative 1y and then minus 5iy, okay? So similar to the first problem, I want to take the second equation here, okay? Just to make sure that you will get the same thing if you take the first or the second, okay? So let me do that. What I want to do is, I want to move that to the to this side. I get 2x equals to what? Negative 3y minus 5iy. Okay, let me take y out. So 2x equals to negative 3 minus 5i, and then y is outside. Let me divide both sides by negative 3 minus 5i. So you get y equals to 2 over negative 3 minus 5i times y. You see that? Oh, sorry, x. X, right? So 2x over that, right? 2x over negative 3 minus 5i. So what should I take for x to cancel this one? Okay. So if I take x equals to negative 3 minus 5i, what do I get? Then take x equals to negative 3 minus 5i. Then what do I get? Then y will be what? Y will be basically 2, right? Because that will cancel out, and then you will get y equals to 2. So basically, what is the vector then? So the vector eigenvector will be negative 3 minus 5i and then 2. So how are they related? Look at this. What do we get here? For the first one, when the eigenvalue was 1 minus negative 1 plus 5i, then the eigenvector is 3 minus 5i. So how about here? We are taking the conjugate of that, right? This eigenvalue is conjugate of that, the first eigenvalue. Then what do you get? V equals to negative 3 minus 5i and then 2, right? So if you take negative sign out, what do you get? You get 3 plus 5i negative 2. You see that? Look at this vector and that vector, v equals to, right? So don't worry about this vector v, because anything parallel to this vector will also be eigenvector. Okay, don't worry about the negative sign. But what we can see inside is, see, this vector is conjugate of that vector. You see that? This vector is the conjugate of that vector, meaning that what we can say from here is, if an eigenvector, if a plus bi, let's say a plus bi is eigenvector of a matrix A with real coefficient, because all those matrix A, the entries of matrix A are the real. Okay, if a plus bi, let's say if a plus bi, okay, is an eigenvector of a matrix A with real entries, then its conjugate a minus bi is also an eigenvector of the same matrix A. You see that? They are conjugate to each other. That's why. Okay, guys? So you can say that if a plus bi is an eigenvector of a matrix A, then a minus bi is also an eigenvector. And you may be wondering, why, how can you say a plus bi and a minus bi for that? I mean, you can absolutely write that way, right? How? Because you can write that, so 3 plus 5i and then negative 2. This can be written as 3 negative 2 and then plus I times 5 0. You see that? So see, 3 plus I5 and then negative 2 plus 0, that is negative 2. So you can write this is like a plus ib. So a and b are vector here, but you can definitely write this as a plus ib. So this is like a plus ib and this is a minus iv. Okay, so you can write either way. All right, so if a plus ib is an eigenvector, then a minus iv is also an eigenvector. I mean, you got an extra negative sign here, but no worries about that. We could get extra negative sign there too if you were working like just if you distribute this negative 3 minus 5i, in that case you would be multiplied by negative 3 plus 5i here. Okay, and then you get the plus 2 here in that case. Okay, but